Good morning, everybody, or afternoon, or whatever time of day it is. Hard to tell. Thanks for showing up. Appreciate it. What we're going to cover today and what we're going to go over are just some of the small detail things and things you can exploit and take advantage of in Mastercam to just get things done faster. Oftentimes one of the biggest complaints or criticisms I hear about not just Mastercam, but a lot of CAM systems is that every time you start a new part, you always feel like you're starting literally from zero every time. You don't have your tools, you don't have your fixtures, you don't have your machine. You're starting with just that blank screen every time and maybe just a print or a solid. And it always feels like this, like the first 20 or 30 minutes of any programming job you're doing is just getting yourself ready to go. So what we're going to look at today is how can I sort of over time sort of build up a broader database of things I'm working with, fixtures, tool databases, operational databases, templates, anything that is going to get me further along that curve when I start a project. I don't have to always be starting from zero. So what we're going to look at are just sort of a list of just little things that have huge gains when you kind of do them collectively, or you sort of build them up over time. And the first thing we're going to look at, and this is one of those things that's really, really easy to miss if you don't know that Mastercam does this, is the first thing we're going to look at is taking advantage of Mastercam's use of tool data when I'm programming. And to do that, what we're going to do is I've just got a generic part open that's already been programmed. And what I'm going to show you is how to access certain factors of tool data to just make things go a little quicker. So if you've ever experienced or looked in the tool settings page on your machine group properties, you may have noticed this little field right there. Use a tool's step, pec, and coolant value. I think I used Mastercam for many years before I ever even thought about checking that box or looking at what that box does. And this is one of those boxes that you can, pretty much ignore for years and years. And then once you discover what it does, you're like, oh, why wasn't I using that the whole time? So this option here to use a tool's step, pec, and coolant option is directly tied to the tool data of whatever tool I'm using. So with that option checked, when I'm setting up or I'm creating a tool, and I'm just going to go into my tool manager and just look at one of the tools I've already got pulled in, and I'm just going to go ahead and grab this 3/8 flat end mill, pretty typical end mill, and I'm going to go ahead and I'm going to look at the tool data. And I'm not looking at the geometry of the tool. I'm looking at the second page, the tool properties page, because there's some fields here that I can take advantage of. Specifically things, like putting in a default feeds and speed for that tool. If it's got a recommended feed and speed or feed per tooth for that given tool, I want to put those values in here. If this thing is designed to run at 10,000 RPM with a feed per tooth of 5, I want to make sure that when I grab that tool, those feeds and speeds are going to come along for the ride. I don't have to re-enter them. I can still change them. They're not written in stone. But, the tool is coming in already with a set feed and speed, which is nice, especially if it's, a tool that I use a lot. The other thing I can do on here, or several other things I can do on here, is I can assign on my tool data page a coolant command specifically for that tool. So if I'm always using that tool and I always want to go ahead and have it automatically use a flood command, when I grab that tool, it's going to turn that on for me. I won't have to remember to do that, or more likely I won't forget to do that and then discover I needed to. But the really interesting one is over here on the right side. And this is a little different for different types of tools. So drilling ops will have pec values, milling tools will have step values. And I've actually got the ability to set both a rough and a finish XY step for that tool. So if this is a tool that I use a lot with dynamic mill, you know, it's primarily going to be a roughing tool, and I might have a dedicated step over value, say, let's just park it at 12%, right? So every time I grab this tool and I'm using a dynamic mill or something that uses an XY step over percentile value, it's going to drop in that 12% that tool wants to run at. You know, and if I've got my feed and my spindle speed and my step over already, you know, self-populating, you know, those are three more things I don't have to remember to change. You know, I'm, again, just further along that curve. For things like an OptiRough or a 3D style toolpath, there's also a Z step down percentile value. So just like you have that step down page on an OptiRough, I can have that auto-populate as well. So, you know, if I'm using this on an OptiRough, I tend to use probably, say, 100% of the tool's diameter for a step down. You know, it is a percentile, so you do need to know what percentage you're looking for. But once you know, it's fairly easy. You know, and then if I am using a finish on this, or I want to use this for a finish style toolpath, you know, something along the lines of a ball or a bull nose, I can also set you know, overall X, Y, and Z step down for a finish pass, right? But we're going to treat this just as a roughing tool, so we're just going to go ahead and have 12% for a step over and a feed of, you know, feed of 10,000 with a feed per tooth of, what did I put, 5? 5, there it is, okay? So I'm just going to hit finish to save that tool data out, and it does ask me if I want to update. I do want to update it. So that's tool number 3 in my catalog. So we'll just see if that worked. I'm just going to take this part and I'm going to write just a really simple dynamic mill. I'm going to check to make sure real quick. Did I check that box? I did, to use that. I just always forget to check that sometimes. So with that checked, when I do something like a dynamic mill, and we'll just do a real simple inside strategy here. So I'm just going to just do that pocket right there with a 3/8. When I grab tool number 3, there's my spindle speed, and there's my feed per tooth. So it drops that in immediately as I select that tool. When I go down to my cut parameters page, I should see my XY step over percentage automatically drop in at 12% or whatever I had it set for. You know, those are 3 things I don't necessarily have to remember to do every time. You know, it's just closer. If I go down and check my coolant command, it turned on my flood. So auto-populating stuff like my spindle speed, you know, my feed per tooth, you can also do plunge and retract rates as well. If you look at that tool data page, there's a lot of things you can sort of auto-populate. You know, I can set plunge, retract, again, feed for spindle and feed rate, feed per tooth, coolant, but those step overs are the ones that I really like because, you know, certain tools obviously run within a certain range, you know, of radial step over value. And if I already know what that is, I want to make sure, you know, that when I grab that tool, it's grabbing that value. It's a very, very simple thing to do, you know, especially on a tool you've been using a lot because you know what you're going to run it as. I don't have to go look it up. I don't have to go find my notes or the post-it note that I scribbled it down on what I was going to run it as. You know, it's there on that tool and it stays that way. You know, that tool's in a database. You know, once I change those, pretty much whenever I decide to grab that specific tool, I'm going to get those values to auto-populate on the toolpath that I'm using. It's a small thing, but it's a huge time saver, you know, because how many times have you been digging around trying to remember what you were supposed to run something at, you know? Easy way to sort of remove that, you know, what you would call, you know, where you can't remember or you can't find it or you're not sure. You know, if it's proven out, just reuse those values. Really, really, really very simple to adjust the tool data. And again, as you notice, once I changed it and updated it, that's in the database. So from now on, that tool is going to run at those values when I select it. You know, this part program, another part program, as long as it's that same tool, those values are good. Okay? So just a really, really simple kind of thing to do. We're not going to keep that toolpath. That was just to show you the auto population. But I do got to remember that is the function that allows me to do that. If that isn't checked, then it's not going to auto-populate those values. That works for milling and drilling equally as well. The drilling ops give you step or peck values if you're peck cycling, that sort of thing. Okay? Now, another thing that you can do to save yourself a little bit of time, and certainly this is something I kind of definitely recommend, and there are a couple of different ways you can approach this. When I'm writing a toolpath, like a facing routine, say for example, that's a pretty one that you're going to use a lot. How many times have you gone on the cut parameters page when you're doing a facing routine and you've forgotten that Mastercam automatically always wants to leave that 50 thou? That's an easy one to miss. I'm about 50-50 with those guys. Now, if whenever I'm making a change in a toolpath, there is a button up at the top of the toolpath window that asks you, hey, you can save those parameters to a defaults file, right? And that's not a bad way to do it. Although what I usually try to tell people is that, if you do update that default from here, that updates all the changes you're making in here. And that includes stuff on the linking parameters page or arc filter page, all of that stuff. And that may or may not always work on every single toolpath. What worked on one might not work on another part. So what I usually tend to have people do or recommend you do is not necessarily just, sort of use this button a lot, the save parameters to default. It's not a bad button, but there's actually an easier way to sort of make those simple changes, not, the whole toolpath changes, but just little fields here or there. And again, it means I'm going back here to my machine group parameters. And this is one of those things where, you may not know it's there. When I selected and run a toolpath in Mastercam, fields are already populated with values. Certain things are turned on, certain things are turned off. It just depends on what you've got and what you're working with. So if I want to have those values be closer or similar to what I'm using, without always having to change them, with always having to take that 50 thou off the wall or off the floor, or to always use a profile entry, my comp is always set to wear instead of control, or I'm using an arc filter all the time. I don't want to have to constantly be changing those values every time I write a toolpath. So in the machine group parameters or machine group properties page, on the files page, down on the bottom, you do have access to the operational default database. And if I come over here and I click on this little exclamation point, I will now be looking at, in this particular case, every single one of Mastercam's milling operations. This works for lathe as well. There's an operational default database for lathe. But this is every milling toolpath that Mastercam can do, even the ones you don't have access to. And there's 85 of them. If you ever wanted to know how many there are technically 85 if you count the stock model. So if I look for something like a 2D toolpath and my face mill, there it is, there's op6, that's the facing operations. Every time I grab a facing operation, these are where the default values are coming from. If I just change the parameters in the database, say for example, that 50 thou on the floor, and I always want that to be 0 because I'm never leaving 50, or I'm leaving 50 a lot, or I'm leaving 0 a lot less than I'm leaving 50, I'm going to change it there. Because now, every time I open up a facing routine, that's going to be 0. It's not going to be 50 anymore, A simple change like that, if I'm always using depth cuts on my facing operation, I can turn them on here and have them activated when I create the toolpath, okay? Big one, and especially a big one, depending on how you like to do your linking parameters, when you open up a toolpath, it always seems like half the values are absolute and the other half are incremental and clearance is never turned on. Well, if I'm the type of programmer that, I just like to use absolute values everywhere, I can just always have this toolpath come in already set to be absolute values, or conversely incremental if I'm more comfortable using incremental. If I'm always using clearance, I don't want to have to turn that on every time. I'm just going to turn it on in the default database, and then it's just on from here on out, right? I would then have to turn it off if I didn't want to use it. And a big one for me, especially if you're using anything that's tricordial or dynamic, is the arc filter, because for the most part, without fail on Mastercam, the arc filter is always turned off. And the arc filter, if you're familiar with it, can drastically reduce the size of your toolpaths and the amount of code you're generating, because you're creating arcs instead of doing everything as a point-to-point sort of move. So, for me, if I'm using traditionally on this toolpath a dynamic style of facing routine, which I tend to, then I definitely want to have my arc filter turned on, and I can set those values to, whatever values I tend to prefer, loosen the tolerance a little bit, put more emphasis on creating arcs instead of straight lines. I won't have to do that every time I use a facing routine. This would be the new default toolpath. So I'm going to make those changes. I'm going to remove that 50 from there. I'm going to leave depth cuts turned off, and I'm going to set everything for an absolute value. Okay? So I'm just going to green check. So just real simple changes, not very, very specific ones, but just things that I find myself changing constantly. If I don't, make them sort of universal. So I'll say okay, and then I'll say okay out of here. And now when I go ahead and I write a facing routine, and let me go ahead and do that really quick. And I'm not going to chain it. I can use the stock definition for that, as you know. When I go to my cut parameters, that 50 is not there, right? Gone. When I go to my linking parameters, they're all set to absolute values, what I want. And if I go down to my arc filter, it's turned on and set the way I want to use it. Very simple adjustments, right? So what I usually recommend for people to do is, sort of keep a mental track or keep a mental list of the values you find yourself changing constantly. Gee, I'm always having to drop that stock to leave. I'm always having to set it for absolute. I'm always having to turn on the arc filter. Just make those changes permanently, and you don't have to do that every time. So you're not starting from zero. You're starting closer to your toolpaths. Little common sense adjustments like that can really save you a lot of time. To the point where if you do this, at some point you'll forget that these were adjusted defaults and you just assume that this is how it always is, and then you get a new version, and it's a little different. But, what I would say is don't necessarily just change everything, because then you find yourself changing a lot of stuff back. But those little adjustments, absolute or incremental, stock to leave values, arc filtering, things you're just always having to kind of set to what you tend to use. Make those changes in the database so that's what they are when you generate or create that toolpath. Again, just further along that curve. That's what this is all about. So you're not keeping that toolpath either, because we're just writing these for fun. So that is what I traditionally refer to as a front end sort of adjustment. Making the tool have the values that I need when I select that tool. Having the toolpath itself have more of the values I'm using when I choose that toolpath. Now, the flip side of this, or the reverse side of this, is what we call a back-end adjustment, or what some people refer to as a recycling of a toolpath, right? If I've written a toolpath and it's working and it's run on a machine and it's proven, for me, that toolpath is worth its weight in gold. It's a shame that after you finished a part file and you finished writing the toolpath and it's run, for a lot of us, that's the last time we ever see or think about that part. And you put a lot of work into generating good toolpaths and they run and they work. It's almost kind of criminal that they're just going to be kind of just stuck in that part file forever. So one of the things I really, really strongly encourage people to do is start building up a good database of proven toolpaths that you can reuse over and over, okay? So what I'm gonna do is I'm gonna show you just a real simple method for exporting toolpaths, organizing them, and then re-importing them in on future parts, okay? So what I'm gonna do is I'm just gonna go ahead and pick a couple of toolpaths here that I wanna export, ones that I thought worked really well or they ran on the machine and they were pretty decent. And the first one I'm gonna grab the facing routine. And then I'm going to grab a couple of the dynamic mills. Okay. So in my toolpath manager, if I right click pretty much anywhere in a blank spot, I get a command for export. And this allows me to cherry pick and export toolpaths from this part file and put them someplace where I can access them again and again and again and again. Okay. So I'm going to go ahead and select export. And you can make this window bigger, obviously. And there's every toolpath in this operation or in this part file. And I'm going to go ahead and export them to a database. And the first thing I'm going to do is choose a different database. Because if I export these as is into Mastercam's default database, they're going to get lumped in with those 85 other toolpaths. And it's going to take me much longer to find those again. So I want to put them someplace that's my database. And the way I sort of describe this is, I tend to describe it almost like your tool chest, right? So I've got a tool chest for toolpaths, and I've got different drawers for different styles of toolpaths or different drawers for different materials, however you want to do it. You know, the organization of it is kind of up to you. But what I'm going to go ahead and do is I'm going to click on this button in the top right-hand corner to go ahead and just find a different place to park these, because I don't want to mix them in with the other 85. I will not be finding them anytime soon. So what I'm going to do is I'm just going to jump to one of my external drives. And sorry, you guys are seeing some stuff, but here we go. Here is my ops folder. And in my ops folder, I've got a couple of different subfolders for different types of material. Okay? This is just one way you could organize. So I'm going to assume this was aluminum. There's nothing in here yet. I just kind of created a basic structure just as an example. But I'm going to go ahead and put this in the aluminum database. And I'm going to call this, you can call it whatever you want. I'm going to just call this good aluminum dynamics, right? So dynamic toolpaths that are good for aluminum. So there's my database. That's where it's going to go now. Right? So now I'm just going to cherry pick the toolpaths that I want to use. And, if you don't know this, if I hold down my control key, I can just go ahead and just select the ones I want to grab. Yeah, I want to grab, let's grab that outside one. There's good. And let me grab a good inside one. So I've got a facing routine, an outside dynamic, and an inside style dynamic. So just grabbing a couple of toolpaths. And then I'm going to go ahead, hit the export button. And Mastercam is going to do some flashing lights, and it's going to tell me, hey, I've exported 3 operations successfully. If I look in that database, and I'll go ahead and bring it over on this screen, you guys can see it. So apologies. There is that operational database. So those toolpaths now exist in here. Those 3 are sitting in there, and I can use those over and over and over again. So after it's exported, I'm just going to close this window, and I'm going to move on to a second part because I want to show you the import side of things. So I'm just going to go ahead and clear this guy out, and I'll open up a second part file. So I'm just going to grab a really simple solid model, but that's not the one I'm looking for. Here we go. So just a really simple solid model, right? Now we're going to set this up properly in a second, but I'm just going to show you how easy it is to import these toolpaths. Now, this guy is not quite aligned, but I'm not too worried about that. What I'll do is I'm just going to grab a simple machine and just grab a default mill. And I can throw stock around and do all that kind of stuff, but I want to show you the import side of things because it's very, very easy to do. In fact, it's almost too easy once you learn a couple tricks. There's 3 ways you can import toolpaths. The first way, and probably the sort of the basic way, is if I just right-click in that toolpath manager again, I can use the import function, right? So I'm going to grab the import function, and again, what I need to do is find the database or my tool chest that has my operations in it. By default, it wants to look in the default database, and again, there are those 85 toolpaths, and I'm not going to find mine in there very quickly. It's going to fill up pretty fast. So I'm going to use that button in the top right to go ahead and find a different operational database. I'm just going to go back to my external drive. There's my ops folder. Hey, these were aluminum. And there's my database. Yep, good aluminum dynamic. That's what I want. So I'll grab that. I'll say open. There are those 3 toolpaths. Now, a couple things I'm going to do is I'm going to go ahead and assign whatever the current system, planular system I'm using, and not use the one that these were created with, right? They might have been using a different offset. They might be in a different plane. You know, that doesn't matter because I can override whatever planular data these had initially with whatever I'm using now, you know. So I don't have to go in and necessarily change the planes and change the offset because I can just override them with what I'm using. So I'm going to go ahead and grab my 3 operations, my face, my outside rough, and my pocket rough, and I'm just going to go ahead and import them in. Okay, 3 imports, operations imported successfully. I can just close this window. If I hit the blue plus again, I just grab those 3 again, so you just close it out. And there are those 3 toolpaths from that previous part file now being used in here. So I'm just going to do a really quick setup on this. So I'm just going to throw a bounding box around this. You know, I'll go ahead and make it a little bit bigger. If you guys didn't know, you know, with the bounding box, I'm just going to go ahead and make this say 2 1/4 in X, 8 1/2 in Y, and I'm going to go ahead and click on the top. If I can get my mouse over there, I click on the top face and add myself, say, you know, an extra 1/8 of an inch on the top of the part, right? Basic, simple stock setup. Okay. I'll go ahead and transform it really quickly just to get it in the position that I want. There we go. You know, now the part's in the position I want. I can define my stock really fast, doing a quick all entities, and you know, I'm ready to start toolpathing. So, you know, for my facing routine, I don't need to chain it, although I probably will because I tend to. So I'll quickly add a simple wireframe chain around the box. I'll go into the parameters and pretty much, you know, depending on how I have it set it up, I may have to come in and adjust my values, my depth a little bit. Yep, I need to throw some depth on there. So I'll just go ahead and get that going. But all these values are here. I've got the tool I'm using, the feeds and speeds I used before, the same cut parameters I was using before. You know, it's exactly the same toolpath I was using. The only thing I may not need, I may not need depth cuts sometimes. So in this case, I'm going to leave them on, but I'll green check. There we go. My next toolpath is a 3/4 end mill. It's an outside dynamic. So I'll go ahead and just chain that really quickly. So it's an outside strategy. Again, I'll C-plane chain around that stock boundary. I'll throw a really quick avoidance using some solid chaining options. I'll use outer edges in this case to define a avoidance boundary to keep that part or keep that tool off there. There we go. I'll go into the parameters for that toolpath, and again, I shouldn't really have to change anything. If I go down to the tool page, I'm using the tool I want to use with the feeds and speeds I want to use. My cut parameters are all set up from the last time, so I'm leaving 10 on the wall, so it's the same toolpath as before. You know, I can look at either depth cuts or whether I want to use breakthrough, but probably the only thing I really need to do is take a look at the depth I'm going, because I don't have a depth set. So I'll set my depth to the bottom of that material. There we go. My arc filter is already set from the last time I used it, so this should all be good. So I'll simply green check. Now you notice I haven't regenerated anything yet. I'm just waiting till I'm done. I don't, you know, I could regenerate them as I go, but I'm just going to wait till I've got all 3. The last one is a 3/8 mil on the interior here, so I'll go ahead and I'll just chain those and inside strategy. So, and again, what I'll do is I'll just do a simple loop chain. There we go. That looks all right. I'll go into the parameters using a 3/8 stocks. You know, everything there is set the way I want. Entry motion is the entry motion I like. It's a profile, 30 thou above. 1.5 is a plunge angle. You know, I may choose to add breakthrough or something if I need to, but I'll just go to my linking parameters and I'll go, okay, top of stock. Well, that's changed a little bit, so I can just change that and change my depth to the bottom of the part. Arc filter, again, set from how I was using it previously. So I'll just go ahead and green check to generate that. Now, with all 3 of those given information, at least as far as, you know, where they're going in X and Y for my chain data and where they're going in Z for my linking parameters, I'm just going to select all three and just regenerate them. And very quickly, you know, I've recycled those toolpaths. You know, the only thing I noticed, maybe those depth cuts are a little on the cautious side, so I may want to change those. But the point being, I am not doing all of these from scratch. You know, even if I go through and I adjust my defaults, you know, these are dialed in toolpaths. These have run. You know, that's kind of the ones you tend to use for export and imports, ones you've actually proven out. That's a good toolpath. Why would you leave it trapped in another part file, you know, for eternity? So that's one way to do it. Now, once you get them imported in, you know, basically you're chaining them and setting depths and making whatever little adjustments you may have to make. But again, you're not starting from zero with every single toolpath. The other thing you can do here for an import, and I'll just show you this, because this is kind of fun. So, you know, the traditional way to import is simply to right click and use the import function. But you can actually do this faster. If I have the database open, in other words, literally if I have it open on my screen, all I need to do to import a toolpath from a database is, and I'm not making this up, this is as easy as it is. I'm just going to left click on that database and I'm just going to drag and drop it into the toolpath manager. And I am automatically set to be on the import page. Right? Really nice, really easy to do. I can even do you one better. Right? I don't even actually have to go through the hassle, let's say, of exporting a toolpath. If I've got a part file, I can actually just drag the part file in, and use this sparingly because this has the potential to be it's a bit of a game changer, especially if you can remember what that part file was. So let me find that part. I put it in a strange place, so hang on. Okay, so there it is. So this was the part that I was playing with here. That's the one I exported from, right? So it's one if you've taken the Essentials class, you've probably recognized that part. It's been around. So this is a completed part file. If I actually just click on the part file and drag and drop the part file into the toolpath manager, I can import and cherry pick whatever toolpaths are in that part file. So hey, I want to grab, yeah, I want that facing routine, I want that dynamic, and I want that dynamic. So boop, 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 import them in, there they are. So I don't even actually have to go through the hassle of exporting toolpaths. I can just recycle them from part files I've already written. You can do that. It is sometimes tough to remember which ones you're trying to grab, but that's a really quick way to do it. So if I've got toolpaths that are proven out, you know, and I think I'm probably going to use that one a lot, or I find myself using something similar, export it and just recycle it over and over and over again. If you're a lathe programmer, this really needs to be sort of your standard operating procedure, because you're traditionally doing a facing, a rough, and a finish on a turning operation over and over and over and over again. And they're usually not too different from each other because your parts tend to be somewhat similar. So why wouldn't I use the same 3 face, rough, and finish turning toolpaths over and over and over again? I'm just going to re-import them each time, you know, and just reassign, rechain them. And again, make a couple adjustments here or there as you're needed, but I'm working with a toolpath that has already, you know, proven its worth, so to speak. You know, I'm not guessing as much, or I'm not wondering, hey, is this going to work? I know it works because I've used it. I do that a lot. I do a lot of exporting and importing. And over time, you're going to build up a really substantial database, you know, and sort of tool chest of toolpaths that you like, that you wrote, that do work. You know, very much worth the time and effort to do that. Absolutely. So a couple different ways to do some exports. All right. So what we want to talk about next are a couple of things to help you on the setup end of things. You know, because, you know, exporting and importing toolpaths, adjusting tool data, adjusting, your defaults, that sort of thing. That helps you on the toolpath side of things. It can help you program faster. But sometimes it's just nice if I can just sort of get the part sort of onto my setup and go. So what we're going to look at is a couple of just basic concepts for creating simple templates for your programming, especially if you find yourself programming sort of on the same machine with the same vise in the same position a lot, and this is also nice if you do a lot of, quick parts or one-off parts and you need to get it on the machine and go without a lot of guesswork. So we're going to look at a couple of template ideas, one for a simple 3-axis setup and then one for a little bit more advanced 5-axis setup, right? Okay, so what I'm going to do is I'm going to open up one of my template programs. So bear with me a sec while I get back to that location. Okay. So this is a simple template idea, okay? And I'm going to turn a bunch of stuff off so we can kind of just look at how this is created, okay? So the first thing is I've got my vise in there, right? And this is just a Curt 3800V downloaded from Curt's website. It's got step jaws on it, to reflect the vise that we actually, that we use. And it's got a stopper, that I may or may not have, that may not be your stopper, but I've got the basics of that setup on the machine already laid out. I've also got a plane created specifically for that setup, and it's just set up off the vise. And depending on how you like to set up your work offsets and where you like to locate them, wholly up to you. I've just got it set off the back corner of the vise because hopefully that's the one thing on the table that never moves around on me. So, and this is just the idea of just kind of dropping in and setting up very, very quick templates, right? The other thing I have on here is I have a second vise for the flip, which is really just the same vise, right? I mean, if I turn them both on, I'm using the sandwich board method, right? I can suspend a part kind of between two vices. And I've actually got set up down at the bottom a couple of quick view sheets, right? And if you guys aren't using view sheets, I highly recommend, you start looking into them, especially if you're doing something where you're doing multiple setups. So my view sheets down at the bottom, one set up for op2, one set up for op1, just allow me to switch between one vise and the other vise flipped. And they look identical to each other, but I'm actually switching, 180 degrees. I'm also changing from my first plane to my second plane via view sheet. So it's kind of already set up there for me to sort of flip this part around and work with it, okay? Now I've got some other things thrown in there to help me out a little bit. I've got an assumed piece of material. So I've actually got just a solid mocked up as a piece of plate stock. And it's, I think, 5 by 10 by a ½ inch, right? Just basic, simple piece of plate, right? So if most of my parts or, the stuff I'm making quickly sort of fall into that, I can make some adjustments to the size of that, but I've already got stock sort of, sussed out there. So what I'm going to do to set this up is, this is my basic template. I've also got, just to show you what else we've got in here, in my toolpath manager, I've got a couple of different groups set up. I've actually already got a stock model created off that basic plate stock, just because I tend to use stock models. So that's already hanging around. And I've got a couple of, toolpath groups already created to plug toolpaths into, right? So, and in my tool manager, I've also got, the tools that I have on that machine, or a representation of the tools I have already loaded in, right? So my tools are already there as well. So I've, got my created tool database, and I've just already got it assigned to this template. So this is my starting point. I've got stock, or at least, an assumed piece of stock. I've got my fixtures, I've got my planes, I've got my tools. I've got my machine loaded. I'm not starting from zero. I've got most everything I need to, quickly turn this part around. So that's what I'm going to do. I'm going to go ahead and just basically go up to File and do a merge. And I'm going to grab the part I want to machine. And it's that little part we were playing around with, right? So I'll go ahead and find my part. Oh, yeah. Typical Mastercam. I was only looking for Mastercam files. So here's a step of the part I want to make, just a simple plate piece. I'll go ahead and hit open. There it drops in. You know, not the best, not in the best location, but I'm just going to green check because I'm going to go ahead and do a really simple alignment. Now I've got a stock boundary laid out, and I can turn other stuff off if I want to. I've got a stock boundary laid out here, okay? And what I'm going to do is I'm just going to take this part, and I'm just going to quickly center it in that material, and I'm just going to use a dynamic transform to do that. I'm going to use a temporary midpoint, so I'm just going to grab, say, this corner here and this corner there. Hey, there's the midpoint on that guy. Yep, go ahead and locate it there. I'll go ahead and swing it 90 degrees. And I'm going to go ahead and move my gnomon down to the bottom of the piece, and then just align the bottom of the part to the bottom of that material. You can see that part is exactly as thick as that material. So there we go. Okay? It's centered in that material. Okay? Now, what we're going to do is we're going to program this, or show you how to program this to use what is referred to traditionally as a picture frame style, right? Because I want to be able to program this quickly without having to create soft jaws to hold it for the flip or do anything like that, right? So if I'm going to, you know, machine on both sides of this, I just want to be able to flip the whole piece in the vise, you know, and then use the material sort of as its own fixture, right? That's a very quick and nice way to do that. So with that part located, I can start looking at some toolpaths. Again, I've already got my stock defined. I've already got, my vise. I've already got all that stuff ready. So once I've got it where I want it, I can start creating toolpaths. And if I want, I can then immediately start importing toolpaths that I have lying around, right? Which might not be a bad idea since we were looking at using an import, okay? So what I'll do is I'll go ahead and look at that database, and I'll go ahead and I'll import some of these toolpaths. So again, I'm just clicking and dragging. That's kind of my preferred way to do it. I don't use the import buttons too much. I just tend to drag and drop. And I don't need the face routine, so I'm just going to go ahead and I'm going to grab this guy and this guy. So the two high-speed dynamics. And I'll say OK. All right. Now, this first toolpath is my dynamic. That's the outside one. So I'm just going to machine around the outside of the part. And again, I'm just programming it like I normally would, right? So from outside, oh, sorry, this would actually be an inside strategy. My apologies. So we'll do a quick chain around there, boom. And I'm gonna have an avoidance region, which again is gonna be the part itself. Go ahead and do that. You know, I've already got the tool selected. I'll go ahead and grab, there's my 3/4, it's already all pulled in there. So I'll just set my cut parameters. Yep, that's what I want to do. Step over is where I want it. Linking parameters, I want to go ahead and set those correctly. So I'll set at the top of stock, I'll set the depth. There we go. And I should get a pretty reasonable toolpath around that guy. There we go. Now I'll do the same thing with the second toolpath. So an inside strategy, again, I'll do these as loops. So real similar to what we're just doing, just recycling what I've already done. Using the 3/8, I'll set my linking parameters the way I need them. Green check, regenerate, right? Fairly straightforward. Now, I did do a couple of things differently when I did this, and I will show you sort of the completed version here in a sec. So, but that's sort of the basics, right? So I can drop a part into a template, and I've immediately got, everything I need to just start programming, right there for me, and it's what I have on the machine. So let me kind of show you the approach we did for this off the sort of the completed version, so we can start looking at what the picture frame is going to look like. There it is. Okay, so same part, same template, same everything. It's just, like they used to do on the old baking shows. This is one we had in the oven earlier. I'm not going to show you myself programming every single one of these because we don't have the time. But, after I've imported it in, I've written my toolpaths, this is what I have, right? So on op 1, basically, I'm drilling some holes, drilling some more holes. There's my dynamic mill to go ahead and hog out the center. And then I'm using an outside dynamic mill, but the thing I'm doing there is I'm leaving a little bit of material on the edge there. And when we run this and verify, you'll see what I'm going for. Some contours to clean up walls. And then I'm actually going ahead and creating a contour to create a couple of tabs. And if you've never created tabs with a contour, just so you know how it's done, contour tabs are created using the square tab point. If you've ever wondered what that square point is, they're for tabs. So I can place very easily a couple of tab points around wireframe, and when I chain it, I can have my contour use those tabs or use those square points to locate where exactly I want those tabs to be. So very simply, very quickly, very easily, you can drop a couple of points, create a couple of tabs where you want that to be, set the depth, the thickness of the tab, all of that good stuff. So what I'm going to do is I'm going to look at this and verify to see how I'm picture framing that, right? So I'm going to tell verify I want to use that stock, and I'm telling verify I want to use that op1 vise. Okay, and I'm just going to select the op1 stuff that I wrote, and I'm going to take a look and verify. Now, I'm using stock models for a really good reason. Stock models are by far the best way to transfer what I'm doing on one side to the other side. So this is everything I'm doing on side 1. You can see I'm just basically, relieving some material from the part around the periphery of it, doing the holes, doing the things. A little exaggerated with that. I'm just roughing out the basic picture frame and a little bit of engraving and putting in a couple of tab points, right? Now, the important thing I want to make sure I'm doing is that I want all of this to transfer over for the second operation, right? Because that's the part flipped over in the vise. And I need to see what's going to happen when I'm doing the back side to what I've already done on the first side. And I tend to use stock models to make that happen. So, at the end of operation or op 1, I generate a stock model to represent everything I've done there. And that way, when I switch over and start using op 2, that's what I'm looking at for my material. This is the part flipped over in that vise. Same work offset, same vise. I'm just literally flipping the plate over and just having a pair of vices there to represent that. So if I want to run those op 2 operations, which again are just basically, sort of a repeat of op 1, in verify, I'm going to change it to use that second stock model, and I'm going to change to use the second fixture. When I run my op 2 ops, I'm now looking at that second setup completely, and it doesn't take me much to do that because I've already got the fixture created. I've already got the first stock model created. I'm just writing toolpaths and adding stock models and changing what I want to see and verify, So now I should see essentially that part, suspended by those tabs when I'm done. Literally just flipped the material over and machined the back side. Fairly simple, fairly straightforward. Using the same geometry for the tabs as I did on the front side, right? You only have to create one set. And there's the part suspended, in its picture frame. I just have to, bandsaw or clip that out of there, break it out if you make them thin enough. And there I've got a part, without having to create soft jaws, without having to, create an extra fixture, go find some mighty bites or anything weird like that. I'm just going to hold the part essentially in its own material. Very, very quick way to get out, just a handful of parts without having to go through the hassle of creating fixtures for it, And depending on how you like to set your work offsets, you can still get a very, very accurate part doing this. Okay? So that's a really, really simple, straightforward way to sort of approach, very quick turnaround for 3-axis. Just create a couple of vices, have some stock already set up for you, have your plane set up, have your tools set up, drop the part in and just go, because you kind of already know what you're going to be working with or what you're going to be working on. It's a nice way to do it. Now, I'm going to show you sort of this in sort of a 5-axis sort of presentation, or a 5-axis sort of format, because you might find that also very helpful. And it's also going to introduce you to a concept that I call clay bar stock, which is, it's kind of a weird thing. No one ever calls it that. That's what I just decided to call it. But if I'm going to do this in a multi-axis thing, or even a 3-axis, and I need to resize that stock, this is how I'm going to do it. Okay. So I'm going to grab what is my 5-axis template, and this is actually the template that I myself actually do use. So this is set up for the machine we have down in Algona, which is a Haas VF4 with a trunnion on it, and we use 5th-axis vices on it when we're running multi-axis stuff. Now, I don't want to have to, every time I want to run a part in a multi-axis setup, you know, which is a dovetailed piece of material typically, I don't want to have to sit there and model the stock up and do all of that stuff every time I'm dealing with something that already has some machining done to it, right? So what I've got on this is I've got, you know, my basic setup as far as the plane I'm using, right, in the right location for this machine, the fixtures that I'm using downloaded from 5th-axis, and I've got a basic solid piece of stock that already has the dovetail modeled into it, right? So this is assuming I've already got the material sort of prepped for it. And what we're going to do is we're just going to learn a really quick and simple way to resize this material, okay? So I'm going to turn it off for a moment, so my dovetailed stock. And again, I'm going to go to File, and I'm going to go to Merge, and I'm going to grab a solid model, okay? And I'm going to grab this one, okay, which just popped in below. That's fine. I can work with that. What I'm going to go ahead and do is I'm going to select it. I'm going to use my dynamic transform, and I'm going to locate it. And actually, on this guy, all I really need to do is bump this up in Z to where I want it to be. And we're just going to go ahead and place it, say, right about there, leaving enough material, you know, below it to where I can, you know, create a couple of tabs or have a bit of a pedestal for it, right? So I'm just going to eyeball it in this case, but you know, obviously you probably have a set distance. You want that sitting above your jaws. But we'll just go ahead and we'll just park it right there. Okay. Now, what I want to do is I want to go ahead and resize this material to this part. And I'm going to do that by creating a stock boundary, right? So I'm just going to throw a bounding box around this part. Okay? Really simple. So I'm just going to jump up to wireframe and bounding box, select just the part itself, and then I can go ahead and look to resize it. So I'll increase X and Y. So I'll increase X to say 3.5. I'll increase Y to say 2.75, you know, however you want to do it. And I'll go ahead and I'll grab on the top of that surface there, and I'll just increase Z up by, say, 1/4 inch. Okay. I'll go ahead and green check, and there is my basic boundary of material. Now, I didn't extend it on the bottom because I don't need to, okay? Because what I'm going to do is I'm going to turn that solid piece of stock back on, and I'm going to resize it based off that bounding box. And I can do that really easily. And this is what you consider the clay bar side of thing, or the clay stock, right? Using my model prep, right? Because I'm going to use model prep, I'm going to use push-pull. Because when I use push-pull, I can grab, say, the face of the solid and align it dynamically to a point on my screen. And in this case, I'm just going to basically extend this out. Helps if you're, yeah, sometimes translucency helps. You can see stuff. There we go. I'm going to size it to there. I just basically just have to resize the material based off the box itself, right? So I have the material ready, and I'm using the box to determine its size. I just have to kind of work my way around. It's pretty straightforward. There's the last one. Boink. So there is, you know, a very quick way to size up a piece of dovetailed stock based off what I'm trying to machine. I can go ahead and grab this stock model, which I have hanging around, go into the parameters, select the model I want to use now that I've resized it. I can also have it pre-selected, and if I adjust it and regen the stock model, that'll also work. There we go. Regen that. And if I turn off that solid stock you know, I'm left looking at just my stock model. You know, so my stock is already sized up, the parts where I want it, and the stock's there. And then, you know, I can immediately start writing a toolpath because I've already got, you know, because it's a template, I've already got my tools preloaded. And if I've got the tool data filled out, you know, that when I grab these tools, they're coming in. So for example, if I change some tool data on this guy, just to show you, because I haven't changed it on this, all right? So I want some good feeds and speeds on this guy when I use this tool. So again, we'll do 10,000, and I'll do a feed per tooth of, never find it, there it is, 5, which I always get flack for. I'll do a rough step of, say, 12 again, and I'll do a rough Z step of, well, I'll get crazy, I'll go 150%, which on an OptiRough is kind of what I'm looking for. All right, well, that looks about what I need for that tool to work, right? So now when I grab that tool from here on out, that's what I should have. So I'll just grab a simple OptiRough. I'll go ahead and select the part I want to use, you know, stock to leave, all that stuff you traditionally do, toolpath control, you know, again, if I'm importing this or I've already got it set up, you know, then you don't have to do this every time. So I could have this OptiRough ready to go. There's my 3/4. There's that feed and speed value it dropped in. If I go down to my cut parameters, yep, there's my step over. Didn't grab it for whatever reason. Oh, you know why? Why didn't it grab it? Because I did not have this checked. It grabbed the feeds and speeds, but it didn't grab the PEC stuff. I forgot to have that checked. So let me try that again, just to show you that it does work. Always hate it when it doesn't work. Okay. So again, this is just trying to get me further along that curve faster, you know, so I don't always have to be starting from 0. There we go. 3/4, there's my feeds and speeds. Now, here we go. There it is. There's my 12%. Still didn't grab the step down. That's a little annoying. There we are. So there's my step down. I'll turn on some step up. I'll go ahead and set some steep shallows, which again, I can have automatically set up already if I want to. And I'll just go ahead and I'll machine down, say, to this base here. Okay. Arc filter, not turned on. Again, if I have those set up in my defaults, I can have all of that ready to go. And I have this toolpath dialed in much closer to what I want to use. But we'll generate that and we'll see, you know, very quickly, you know, I'm into a toolpath. You know, I'm not burning time, you know, setting up vices or bringing stuff in because I've got that stuff just sort of hanging around and ready to go. So let's see, what did we get? Yeah, so we got ourselves a good OptiRough. And if I go ahead and have this set just to make sure that I'm using that stock model, there's my fixture. You know, I can immediately jump into verify, you know, and I'm, again, just further along that curve faster. You know, I'm already into verify. I'm already evaluating and making adjustments to the toolpath, things I like, things I don't like. You know, my feeds and speeds are there. The step over is what I expect it to be. You know, all of that stuff that I sometimes, you know, either might forget or, you know, those little tiny details that seem to slow down sort of your momentum when you're programming, I can have that already there for me. And it just makes it just that much quicker, you know. So, you know, if you've got a good fixture or a fixture you tend to use a lot, or a machine that's sort of your prep machine where you do quick turnarounds on, you know, try to build that world up as much as possible as a template. So you can just drop parts into it all day long and just program rather than worry about the setup. You know, all of those things, tool data, you know, taking the time to fill that out properly, taking advantage of the ability to auto-populate, you know, exporting the good tool paths and remembering to import them when you get the opportunity to use them again. You know, having a good, you know, a good sort of external database of proven tool paths that you can just dip into whenever you need to. It's lovely. Making templates, you know, for the stuff you have out in the shop, you know, and having those just ready to go. You know, all of those things together, you know, shave, you know, so much time off your programming. You know, because even if I have to burn an extra 5 or 10 minutes, you know, setting up a vise or creating a plane or something, or getting it dialed in, you know, that's 10 minutes I'm not spending on the toolpaths. And I always want to spend the most of my time, you know, messing with the toolpaths, trying to refine them and make it better. I don't want to burn time, you know, playing around with fixtures and stock and that sort of stuff. You know, my time should be on the toolpaths, not on this. So, you know, as you're sort of looking at how you're programming, start thinking about ways you can say, well, how can I have that there for me already? You know, and just that simple sort of just way to approach it. How can I have this sort of ready for what I need to do? Can shave a huge amount of time off what you're doing. You know, not to mention the fact that you don't get burned out doing the same 5 things over and over on every part file. You know, oh, I've got to create a bounding box. Oh, I've got to make stock. Oh, I've got to adjust feeds and speeds. Oh, I've got to change the stock to leave values every single time. It gets old. You know, if I do it this way, you know, then I'm just saving myself work down the road. So, you know, it's definitely even a little bit of this, you know, can definitely save you some time.